Advanced Functions. Grade 12. Unit 8. Exponential and logarithmic functions. In this video, you will learn how to relate logarithmic functions to exponential functions, how to describe the characteristics of logarithmic functions and their graphs, how to evaluate logarithms and simplify logarithmic expressions, how to solve exponential and logarithmic equations, and how to use exponential and logarithmic functions to solve problems involving exponential growth and decay, and applications of logarithmic scales. We will treat all variables as real numbers. Complex numbers are not covered in this video. Let's look at the following equation: x squared equals 9. You know that x is equal to the positive and negative square root of 9, and that is negative 3 and 3. How to solve this equation? 3 power x equals 9. How to find the needed power x? We write that exponent x as the logarithm of 9 to the base 3, and it's equal to 2, since 3 to the power of 2 equals 9. Now let's look at the graphs of the two functions, y equals 3 to the power x, and y equals log of x to the base 3. Since y equals log of x to the base 3, x equals 3 to the power y. So the function y equals log of x is an inverse of the exponential function y equals 3 to the power x. The inverse of the exponential function y equals a to the power x is the logarithmic function y equals log of x to the base a. The general shape of the graph of the logarithmic function depends on the value of the base. When a greater than 1, the exponential function is an increasing function, and the logarithmic function is also an increasing function. When a is greater than 0 and less than 1, the exponential function is a decreasing function, and the logarithmic function is also a decreasing function. The y-axis is the vertical asymptote for the logarithmic function. The x-axis is the horizontal asymptote for the exponential function. The x-intercept of the logarithmic function is 1, while the y-intercept of the exponential function is 1. The domain of the logarithmic function is the set of all real numbers where x is greater than 0, since the range of the exponential function is the set of all real numbers where y is greater than 0. The range of the logarithmic function is the set of all real numbers since the domain of the exponential function is the set of all real numbers. If there is no value of a in a logarithmic function log of x to the base a, the base is understood to be 10. Logarithms with base 10 are called common logarithms. The general formula of transformations of the function f of x is, g of x equals a, f of k times x minus d, plus c. When f of x equals the log of x to the base 10, the transformation formula turns to be g of x equals a, log of k times x minus d, plus c. The absolute value of a gives the vertical stretch/compression factor. If a is less than 0, there is also a reflection in the x-axis. The absolute value of 1 divided by k gives the horizontal stretch/compression factor. If k is less than 0, there is also a reflection in the y-axis. D gives the horizontal translation. C gives the vertical translation. Each point xy on the graph of the parent function will be transformed to the point with the coordinates x divided by k, plus d, and a times y, plus c. Laws of logarithms. The log of xy to the base a equals the log of x to the base a, plus the log of y to the base a. The log of x divided y to the base a equals the log of x to the base a, minus the log of y to the base a. The log of x to the power r, to the base a equals r times the log of x to the base a. Log of 1 to the base of a equals 0. Log of a to the power of x, to the base of a, equals x. A to the power of log of x to the base of a, equals x. Note that the base a must be greater than 0 and not equal to 1. Here is another formula that might be useful if your calculator supports only common logarithms with a base of 10. You can write any logarithm of x to the base of a as a common logarithm of x, divided by the common logarithm of a. Solving problems with exponential and logarithmic functions. pH scale. pH scale is used to compare the concentration of hydrogen ions in the solutions. pH is a measure of acidity or alkalinity of a substance. H+ is the concentration of hydrogen ions in moles per liter. pH equals negative log of H+. Richter scale. The Richter magnitude scale uses logarithms to compare intensity of earthquakes. For example, if the true intensity of an earthquake is 10 to the power 4, the Richter scale magnitude equals log of 10 to the power 4, which is 4. The Richter scale magnitude equals to log of the true intensity. Sound intensity. I is the intensity of the sound being measured. I0 is the intensity of sound at the threshold of hearing. L is the loudness measured in decibels, which equals 10 times the log of I divided by I0. Practice questions. Determine the inverse of each function. Express your answers in logarithmic form. A. Y equals 4 to the power of x. B. Y equals a to the power of x. C. Y equals 3 divided 4 to the power of x. D. M equals p to the power of q. Solutions. Recall that the general formula for the inverse function of the exponential function is as follows. If f of x equals a to the power x, then the inverse function is log of x to the base of a. A. The inverse function is y equals log of x to the base 4. B. The inverse function is y equals log of x to the base a. C. The inverse function is y equals log of x to the base 3/4. D. The inverse function is m equals log of q to the base p. Describe the transformations that must be applied to the parent function y equals log of x to obtain each of the following functions. A. F of x equals -3 log of 2x. B. F of x equals log of x minus 5 plus 2. C. F of x equals 1/2 of log of 5x. D. F of x equals log of -x divided by 3 minus 3. Solutions. Recall that the transformation formula for the function log of x is a log of k times x minus d plus c. A. Since k equals 2, and it's greater than 1, 1 divided by k is less than 1. Therefore, you should horizontally compress by a factor of 1/2. Since a is -3, you should vertically stretch the graph of the parent function by a factor of 3 and reflect it in the x-axis. B. D is 5, C is 2. So, translate horizontally 5 units right, and vertically 2 units up. C. A is 1/2, K is 5. Compress horizontally by a factor of 1/5, and vertically by a factor of 1/2. D. K is -1/3, C is -3. Horizontally stretch by a factor of 3, reflect in the y-axis, and vertically translate 3 units down. For each sequence of transformations of the parent function y equals log of x, write the equation of the resulting function. A. Vertical compression by a factor of 2/5, followed by a vertical translation 3 units down. Solution. A is 2/5, and C is -3. So, the equation is y equals 2/5 log of x, minus 3. B. Reflection in the x-axis, followed by a horizontal stretch by a factor of 2, and a horizontal translation 3 units to the right. Solution. A equals -1, K equals 1/2, D equals 3. So, the equation is y equals log of 1/2, x minus 3. C. Vertical stretch by a factor of 5, followed by a horizontal compression by a factor of 1/2, and a reflection in the y-axis. Solution. A equals 5, K equals -2. The equation is y equals 5 log of -2x. D. A reflection of the y-axis, a horizontal translation 4 units to the left, followed by a vertical translation 2 units down. Solution. K equals -1, D equals -4, C equals -2. The equation is y equals log of -x plus 4, minus 2. Describe how the graphs of f of x equals log of x and g of x equals 3 log of x minus 1, plus 2, are similar yet different. Solution. Similarities. Both are increasing functions. Both are in the first and fourth quadrants. Both have the same range, all real numbers. Differences. Compared to the first, the second graph is a transformed first one. Vertically stretched by a factor of 3. Horizontally translated 1 unit to the right. And vertically translated 2 units up. Evaluate. A. Log of 343 to the base of 7. B. Log of 25 to the base of 1/5. C. Log of 1 to the base of 19. D. Log of 1 256 to the base of 4. Solution. A. 343 can be written as 7 to the power of 3. Log of 7 to the power of 3, to the base of 7, equals 3. B. 25 can be written as 5 squared. 2 can be written as a product of -1 and -2. 5 to the power of -1 is 1/5, which the same as the base. Therefore, the answer is -2. C. Logarithm of 1 is always 0. D. 1/256 can be written as 4 to the power of -4. Log of 4 to the power of -4, to the base of 4, equals -4. Express as a single logarithm. A. Log of 5 plus log of 11. B. Log of 20 minus log of 4. C. Log of 6 to the base 5 plus log of 8 to the base 8 minus log of 12 to the base 5. D. 2 log of 3 plus 4 log of 2. Solution. A. The expression equals log of the product of 5 and 11, which equals log of 55. B. The expression equals log of 20 divided by 4, which is log of 5. C. The expression equals log of 6 times 8 divided by 12, to the base of 5, which equals log of 4 to the base of 5. D. 2 log of 3 can be written as log of 9, and 4 log of 2 can be written as log of 16. The sum of 2 logs equals log of the product of 9 and 16, which equals to log of 144. Use the laws of logarithms to evaluate. A. Log of 42 to the base of 6, minus log of 7 to the base of 6. B. Log of 5 to the base of 3, plus log of 18 to the base of 3, minus log of 10 to the base of 3. C. Log of a cubic root of 49 to the base of 7. D. 2 log of 8 to the base of 4. Solution. A. The expression equals log of the 42 divided by 7, to the base of 6. Log of 6 to the base of 6 equals 1. B. The expression equals log of 5 times 18 divided by 10, to the base of 3, which equals log of 9 to the base of 3. Log of 9 to the base of 3, equals 2. C. The cubic root of 49 can be written as 49 to the power of 1/3, and 49 can be written as 7 squared. Therefore, the expression equals log of 7 to the power of 2/3, to the base of 7, which equals 2/3. D. The logarithm of 8 to the base of 4 can be written as the logarithm of 8 to the base of 2 divided by the logarithm of 4 to the base of 2, which equals 3 divided by 2, and multiplied by 2 equals 3. Describe how the graph of y equals log of 10,000 x is related to the graph of y equals log of x. Solution. Use the laws of logarithms and calculate the logarithm of the product. Log of 10,000 x equals log of 10,000, plus log of x, which equals log of x, plus 4. It means the graph of y equals log of x, shifted 4 units up, equals the graph of y equals log of 1000x. Solve. A. 5 to the power of x equals 3125. B. 4 to the power of x equals 16 square root of 128. C. 4 to the power of 5x equals 16 to the power of 2x minus 1. D. 3 to the power of 5x, 9 to the power of x squared equals 27. Solutions. A. 3125 can be written as 5 to the power of 5. So, x equals 5. B. 16 can be written as 2 to the power of 4, 128 can be written as 2 to the power of 7, and the square root of 128 can be written as 2 to the power 7, to the power of 1/2. Therefore, the right side of the equation can be written as 2 to the power of 7.5, and the left side can be written as 2 to the power of 2x. 2x equals 7.5, which means x equals 3.75. C. 16 can be written as 4 squared. So, the right side of the equation can be written as 4 to the power of 4x minus 2. Therefore, 5x equals 4x minus 2, and x equals -2. D. 27 equals 3 to the power of 3, and 9 equals 3 squared. The left side of the equation can be written as a product of 3 to the power of 5x and 3 to the power of 2x squared, which equals 3 to the power of 2x squared plus 5x. The exponent of 3 on the left side is equal to the exponent of 3 on the right side, and you get a quadratic equation 2x squared plus 5x equals 3, which can be written as 2x squared plus 5x minus 3 equals 0. The expression on the left side can be written as a product of 2x minus 1 and x plus 3, and the roots of the quadratic equation are 0.5 and negative 3. Solve. Express each answer to 3 decimal places. A. 6 to the power of x equals 78. B. 5.4 to the power of x equals 234. C. 8 times 3 to the power of x equals 132. D. 200 times 1.23 to the power of x equals 540. Solutions. A. X equals log of 78 to the base of 6, x equals approximately 2.432. B. X equals log of 234 to the base of 5.4, x equals approximately 3.235. C. 3 to the power of x equals 132 divided by 8, which is 16.5. X equals log of 16.5 to the base of 3. X equals approximately 2.552. D. 1.23 to the power of x equals 540 divided by 200, which is equal to 2.7. X equals log of 2.7 to the base of 1.23. X equals approximately 4.798. Solve. A. 4 to the power of x, plus 6 times 4 to the power of negative x, equals 5. B. 8 times 5 to the power of 2x, plus 8 times 5 to the power of x equals 6. Solutions. A. Multiply both sides of the equation by 4 to the x power and simplify the equation. Let d equals 4 to the x power. Now you have a quadratic equation d squared minus 5d plus 6 equals 0. The left side can be written as a product of t minus 2 and t minus 3. The roots are 2 and 3. Substitute d with 4 to the x power. When t equals 2, x equals 0.5, and t equals 3, x equals approximately 0.792. B. 5 to the 2x power can be written as 5 to the x power squared. Let d equals 5 to the x power. Substitute 5 to the x power with d and the equation will turn into 8d squared plus 8d minus 6 equals 0. The discriminant equals 256 and t equals negative 1/2 plus minus 1. The quadratic equation has two cores, 0.5 and negative 1.5. Since 5 to the x power is always a positive number, t can't be negative 1.5. Substitute the value of t. 5 to the x power equals 0.5. X equals approximately negative 0.431. The half-life of a certain substance is 3.6 days. How long will it take for 20 grams of the substance to decay to 7 grams? Solution. Recall that growth and decay situations can be modeled by exponential functions of the form f of x equals a b to the power of x, where a is the initial amount or number, f of x is the final amount or number, b equals 1 plus growth rate or 1 minus decay rate, and x is the number of growth or decay periods. Since the half-life of the substance is 3.6 days, x equals 3.6, a equals 1, f of 3.6 equals 0.5. Use these values and find the value of b. b to the power of 3.6 equals 0.5. b equals approximately 0.825. Now calculate the value of x when a equals 20 and f of x equals 7. 20 times 0.825 to the power of x equals 7. 0.825 to the x power equals 7 divided by 20, which equals 0.35. X equals log of 3.5 to the base of 0.825. X is approximately 5.46 days. Solve. A. Log of 2x minus 1 to the base of 5 equals 3. B. Log of 3x equals 4. C. Log of 3x minus 5 to the base of 4 equals log of 11 to the base of 4 plus log of 2 to the base of 4. D. Log of 4x minus 1 equals log of x plus 1 plus log of 2. Solutions. A. 2x minus 1 equals 5 to the power 3, which equals 125. 2x equals 125 plus 1. X equals 126 divided by 2. X equals 63. B. 3x equals 10 to the power of 4. X equals 1000 divided by 3 or 3333.333. C. The right side of the equation can be written as log of 22 to the base of 4. So, 3x minus 5 equals 22 and x equals 22 plus 5, divided by 3, which equals 9. D. The right side can be written as log of 2 times x plus 1, or log of 2x plus 2. 4x minus 1 equals 2x plus 2, or 2x equals 3. X equals 1.5. Solve. A. Log of x plus 9, minus log of x, equals 1. B. Log of x, plus log of x minus 3, equals 1. C. Log of x minus 1, plus log of x plus 2, equals 1. D. Log of the square root of x squared minus 1, equals 2. Solutions. A. The left side can be written as log of x plus 9, divided by x. So, x plus 9, divided by x, equals 10. Multiply both sides by x. X plus 9 equals 10x. 9x equals 9, and x equals 1. B. The left side can be written as log of the product of x and x minus 3. X squared minus 3x equals 10 or x squared minus 3x minus 10 equals 0. The left side of the quadratic equation can be written as the product of x plus 2 and x minus 5. Since x plus 2 is greater than 0, x minus 5 equals 0, or x equals 5. C. The left side of the equation can be written as log of the product of x minus 1 and x plus 2. So, x squared plus x minus 2 equals 10 or x squared plus x minus 12 equals 0. Write the left side as the product of x plus 4 and x minus 3. Since x plus 4 is always more than 0, x minus 3 equals 0, or x equals 3. D. The square root of x squared minus 1 equals 10 squared. So, x squared minus 1 equals 10 to the power of 4. X equals the positive and negative value of the square root of 10,001. Recall that L equals 10 log of I divided by I0, where I is the intensity of sound in watts per square meter and I0 equals 10 to the power of negative 12. Determine the intensity of a baby screaming if the noise level is 100 decibels. Solution. L equals 100 decibels, you need to calculate the value of I. 100 equals 10 log of I divided by 10 to the power of negative 12. Log of I divided by 10 to the power of negative 12 equals 10. I divided by 10 to the power of negative 12 equals 10 to the power of 10. I equals the product of 10 to the power of 10 and 10 to the power of negative 12, which equals to 10 power negative 2 or 0.01 watts per square meter. What is the sound intensity in watts per square meter of an engine that is rated at 82 decibels? Solution. Use the same formula, L equals 10 log of I divided by 10 to the power of negative 12. L equals 82 decibels, you need to calculate the value of I. 82 equals 10 log of I divided by 10 to the power of negative 12. Log of I divided by 10 to the power of negative 12 equals 8.2. I divided by 10 to the power of negative 12 equals 10 to the power of 8.2. I equals the product of 10 to the power of 8.2 and 10 to the power of negative 12, which equals to 10 power negative 3.8 watts per square meter. How many times more intense is an earthquake of magnitude 6.2 than an earthquake of magnitude 5.5? Solution. Use the formula R equals log of intensity. So, intensity equals 10 to the power of R. I1 divided by I2 equals 10 to the power of R1 minus R2, which equals 10 to the power of 6.2 minus 5.5, or 10 to the power of 0.7, and the latter is approximately 5 times. Pure water has a pH value of 7.0. How many times more acidic is milk, with a pH value of 6.4, than pure water? Solution. Use the formula pH equals negative log of H plus. So, H plus equals 10 to the power of negative pH. H plus 1 divided by H plus 2 equals 10 to the power of negative pH 1 divided by 10 to the power of negative pH 2, which equals 10 to the power of pH 2 minus pH 1. Use the value of pH 1 equals 7 and pH 2 equals 6.4. 10 to the power of 7 minus 6.4, or 10 to the power of 0.6, and the latter is approximately 3.98 times. The population of a town is decreasing at the rate of 1.6%. If the population today is 20,000, how long will it take for the population to decline to 15,000? Solution. Use the formula f of x equals a, b to the power of x. A is 20,000, b is 0.984, and f of x equals 15,000. Find the value of x. 20,000 times 0.984 to the power of x equals 15,000. 0.984 to the power of x equals 15,000 divided by 20,000, which equals 0.75. X equals log of 0.75 to the base of 0.984. X equals approximately 17.8 years.